Okay, welcome back. So we're going to be looking at factor and remainder theorems today. And this topic should actually be pretty easy for you guys compared to the other Add Math topics. So I don't think it's one you have to worry too much about, but this video should help you consolidate your understanding a little bit more. And before we get started, let's just kind of recap what factor and remainder theorems actually are. So let's suppose I have some function, some p of x equals to, I don't know, let's say x cubed minus 2x plus 5. Okay, so how do we find the remainder that a linear factor would give if we divided this function by that factor? So let's say we divided this function x cubed minus 2x plus 5. Let's say we divided that by, let's say, x minus 1. How do we find the remainder that this would give? Well, one way to do it would just be to do the whole long division method, which you learned in primary school probably, but that's pretty tedious and probably not something you want to do when you're so time pressured in the Add Math exam. So the way you do this in an Add Math exam is what we call the factor and remainder theorem. In this case, the remainder theorem. So what it basically says is that since I have x minus 1 as what I want to divide this by, then what I'm going to plug into p of x is 1. Okay, I'm going to plug 1 into p of x, and that's going to be the remainder. And that's it, that's literally it. So if we do 1 cubed minus 2 times 1 plus 5, that's of course going to be 1 minus 2 plus 5, which is going to be 4. And that's all it is. It's saying that if we divided x cubed minus 2x plus 5 by x minus 1, we get 4. That's it. And that's our remainder theorem. So in terms of the factor theorem, all we're saying is if we have some p of a, let's say a is just some number, if we have p of a and that gives us a remainder of 0, all that means is that x minus a, remember it's minus not plus, so you reverse the sign, x minus a is a factor, and that's it. That's all the factor and remainder theorem is. So hope you guys understood that, and let's go on to the examples now. Okay, so show that 2x minus 1 is a factor of 2x cubed minus 5x squared plus 10x minus 4. So in this previous example we had x minus 1, and we said that if p of a is 0, then x minus 1 is a factor, right? So here we have this 2 as well in front of the x. So let's just think about how we do that for a second. So in this case, when we had x minus a being a factor, we said p of a is 0, which means if we say x minus a is equal to 0, then x would be equal to a, and that's what we plug in over here, which makes sense because we want our remainder to be 0. And so in this case we'd have 2x minus 1 is equal to 0. If we solve for x, that's of course, let's put an arrow there, that's of course going to give us x is 1 over 2. And that's all we want for x. And if this is our function, then we know that if we say p of half, then that has to be 0, since apparently it's a factor of this. So let's just check that works. So 2 times half cubed minus 5 times a half squared plus 10 times a half minus 4, and that's 2 times 1 over 8 minus 5 times 1 over 4 plus 5 minus 4. And if you type that into your calculator, you will get 0. Let's just check it works. 2 times 1 over 8 is 1/4 minus 5/4 plus 5 minus 4, and that's of course 0. And so that's it. We've shown that 2x minus 1 is a factor because p of half is equal to 0, and you can just have a conclusion because p of half is 0, shown factor, or something along those lines. And yeah, that's it. So the next part, hence show that 2x cubed minus 5x squared plus 10x minus 4 has only one real root, and state the value of this root. So immediately you should be thinking, well, if this is a factor of this, and I know that x is equal to half is a root already, then that means that whatever equation I get when I divide this by this has to have no solutions, right? So let's just do that real quick. We know that 2x minus 1 is a factor, and we know we're trying to divide this by 2x minus 1. But how do we get the other equation that times us with 2x minus 1 to get this? And here's where we need long division. So we'll have 2x minus 1, 2x cubed minus 5x squared plus 10x minus 4. Now we know there's going to be no remainder because we just proved that this is a factor. So all we'll have is our divisor here, our quotient here, which should be a quadratic since this is linear and this is cubic. And guys, if you have trouble with algebraic long division, just tell me in the comments below and I can do a video about that. So what we're going to do here is 2x squared, which will get rid of this 2x cubed. Minus 1 times 2x squared is minus 2x squared. And if we subtract these two together, we get minus 3x squared plus 10x. Let's do the same thing again, and this time we're going to have... Oh wait, I think I made a mistake somewhere. Yeah, this should be x squared. My bad. So if that's x squared, then that's going to be 2x squared, and this is minus x squared. Sorry about that. And yeah, so that'll become... You know what? Let me just start this again. Yeah, so let's try that again. We've got 2x minus 1 and 2x cubed minus 5x squared plus 10x minus 4. There we go. Okay, so we know that if we times 2x by x squared, we'll get the 2x cubed that we want to get rid of. And we have to, of course, do this as well. So minus x squared, since that's minus 1 times x squared. Subtract these two together gives us minus 4x squared plus 10x. And 2 times what's going to be minus 4? It's going to be minus 2. And we want to get rid of the x squared, which means we want an x as well. So minus 2x will give us minus 4x squared plus 2x. Subtract these two together gives us 8x minus 4. And 2 times 4 is 8, and we already have the x. So let's just times by 4, and we'll get 8x minus 4. Beautiful. So this becomes 0. We have no remainder, and our quotient, let's call that q. Our quotient is going to be x squared minus 2x plus 4. Cool. But how are we going to prove that this equation here has no real roots? Because we know x is equal to half is the only real root we want. And, well, this is a quadratic. So if we had a quadratic, then what do we do with it to prove it has no real roots? We can use the discriminant, which is b squared minus 4ac. And what is this going to be when there's no real roots? You guys will probably remember this from the quadratics chapter of your Add Math course, that when there's no real solutions, this thing called the discriminant is always less than 0. Yep. And if we have our quadratic here, this is our a term, this is our b term, this is our c term. Let's just check that this works. So minus 2x squared minus 4, sorry, we can remove that, minus 2, since we're just concerned with the coefficients, let me just remove that there. We've got minus 2 squared minus 4 times 1 times 4, and that's equal to 4 minus 16, which is negative 12, and of course negative 12 is less than 0, which means we're done. Since this quadratic equation has no real solutions, so let's just say no real quadratic solutions. And just so we make sure we get all the marks we can, let's just end by saying thus only one real solution, x is equal to half, and that's it, we're done. And oh, we have one more. Okay, so this question, solve the equation x cubed minus 4x squared minus 11x plus 2 is 0, expressing non-integer solutions in this form. Okay, so this should be pretty similar to the previous one, except what they expect you to do, kind of weirdly actually, is that since they don't give you a factor this time, you have to kind of guess which factor it is. So let's use a red pen for that. We've got x cubed minus 4x squared minus 11x plus 2 is equal to 0. And we know there has to be some factor, some number, that when we plug it into all the x's in this, we're going to get 0 out. So the only option we really have at this point is to kind of guess a few numbers. So let's try x is equal to 1. So if we plug x is equal to 1 into this, what do we get? Just use your calculators, and that's what I'll be doing now. 7, 1 plus 2, we get negative 12. So that gives negative 12, which means x is 1 is not what we're looking for. Let's try x is negative 1, and let's see what this gives us. So x is negative 1, all we do again is just sub it into the same thing, and that gives us 8. Again, not what we want. Let's try x is negative 2, for example, and let's see what that gives us. So if we sub x is negative 2 into the equation, x is negative 2, and cool, that gives us 0, which is excellent. So this is what we're looking for, x is negative 2. And guys, just remember that there's no like shame or anything in guessing the factors if they don't give you a factor, because that's exactly what they expect you to do. So it might take a bit of time, but then what I recommend is always go around 0. So try 1, then try negative 1, try half, negative half, 2, negative 2, so on until you get the factor. And it's usually not going to be a hard factor. It'll usually be 1, 2 negatives of those, etc. So now we know that x is equal to negative 2 is a root, which means that x plus 2 is a factor. And the way I did that was just saying that if x plus 2 is equal to 0, it's a factor, then we move the 2 to the other side, becomes x is equal to negative 2. Or in this case, just move the negative 2 over here, and x plus 2 is a factor. Cool. So now we've done the hard part. All we have to do is do the same algebraic long division as last time. And not a particularly fun process, but then, you know, you just have to do what you have to do. So let's just go ahead and do this. Okay, what do we want to times by x to get x cubed? We want x squared. So x cubed, if we times these together, we get minus 2x squared. plus 2x squared, and subtract these two, minus 6x squared, bring down the area 11, minus 11x. So what do we want to times by x to get to negative 6x squared? We want negative 6x. So I'll get negative 6x squared times these two, minus 12x. Subtract them and we get x, just x. Bring down the 2, we get plus 2. And these are the exact same, so we can just times it by 1, get rid of the x plus 2, and boom. That's it. We have our quotient, let's call it q again, of x squared minus 6x plus 1, which is also going to be a factor. And it's a quadratic equation, so what we're going to do is equate that to 0. Plus 1 is equal to 0 to find the roots. And you can do whatever way you like to find the roots. I personally just use the formula on my calculator, so I'm going to do that now. If we say x is 1, sorry, a is 1, b is negative 6, and c is also 1, my calculator gives me x is equal to 3 plus or minus 2 root 2. And you could just work this out using the quadratic equation, which is minus b plus minus square root of b squared minus 2ac over 2a, which is given to you in the formula booklet. And yeah, that's it. So let's just go ahead and conclude and say roots are 3 plus or minus 2 root 2, and let's say x is 3 plus minus 2 root 2, or x is equal to negative 2. And we're done. 6 marks. Last question. Okay, so the expression x cubed plus ax squared minus 15x plus b has a factor of x minus 2 and leaves a remainder of 75 when divided by x plus 3. Calculate the value or find the value of a and b. So, what we're looking at here is two separate ways or two separate factor and remainder theorems, which when we combine them together gives us kind of simultaneous equation from which we can solve a and b. So let's first consider, let's use green for this one. Let's first consider the first case where we have x minus 2 is a factor. So what does this mean? If x minus 2 is a factor, let's just say this is, for example, p of x again. If x minus 2 is a factor, then p of 2 is going to be equal to 0. We know that. So what can we do with that? We've got that we have our equation here. We have p of 2 is 0. So we can just say 2 cubed minus, plus 2 squared a minus 15 times 2 plus b is equal to 0. And so 8 plus 4a minus 30 plus b is equal to 0. And we can just tidy that up a little bit. We get 4a plus b. Let's bring these over to this side. So 30 minus 8 is 22. So that's equal to 22. Awesome. And one equation is done. So what we want to do now, let's use the red pen. We want to work out the second equation. We know that when p of x is divided by x plus 3, we get a remainder of 75. So we know that x plus 3 gives 75 as a remainder. We know that. And from what we've learned, we know that that must mean that p of negative 3, remember, if this was equal to 0, you have to bring the 3 over and you get x is negative 3. So p of negative 3 is going to be equal to 75. Remember, it's not equal to 0 since it's not a factor, but it's equal to 75 this time. Okay. And we do the exact same thing again. We get negative 3 cubed plus negative 3 squared a minus 15 times by negative 3 plus b is equal to 75. And that's the same as saying minus 27 plus 9a plus 45 plus b is equal to 75. And if we just tidy this up a little bit, we get 9a plus b is equal to 75 minus 45 plus 27, which is 57. 75 minus 45 plus, yeah, okay. So we have our two equations, and we know from simultaneous equations that when we want to solve both equations simultaneously, we can either use elimination or substitution. And in this case, I think substitution is probably a little bit harder to do, so I would personally go for elimination. You can choose whichever one you want. So we know that 1 is going to be equal to 2 when they're equal. So we say that, okay, let's say that 4a plus b is equal to 22. And we also know that 9a plus b is 57. Cool. So what I'm going to do now is I'm going to subtract this from this. So I'm going to say this minus this, and that's going to give us, let's use a black pen this time. Let's say that's 5a, b minus b is just 0, and 57 minus 22 is 35. So 5a is 35, which means a has to be 35 over 5, which is just 7, and that's pretty easy. And we can choose whichever equation we want. Let's say we choose this one. Let's sub in the a back in there. So 4 times 7 is 28. So 28 plus b is equal to 22. So b has to be 22 take away 28, and that's of course going to be negative 6. And that's it, we're done. A is 7, b is negative 6. We've answered the question. Hope you guys enjoyed the video and hope it was useful in some way or the other. If you have any questions, please just leave it in the comments. I'm happy to answer them. So see you in the next video.